Hello? Hello? Am I audible?
Yes, ma'am, you're audible.
Okay, so yeah, let me share my screen again. Is this visible?
Yes, it's visible.
Okay. So first question, I think I will come to that question. Last time somebody asked me the geometric interpretation of cross product and dot product. I will come to that. So let's start with some questions. So I think you people know how to compute cross product, right? So can you please compute first question?
The answer would be 16 minus 9 and 5.
16 minus 9 and 5. And how would you do that? Answer is correct.
Yeah, we use a determinant, and the first row would consist of I cap, j cap, and k cap.
Okay.
The second row would have the first vector, and the third row would have the second vector, just the coordinate values.
All right. So if I want to compute A cross B, then it would be how to compute that? Just the determinant, right? I cap plus 1 j cap plus 1 plus k cap 2 plus 3 6 cap minus 9 j cap plus 5 k cap. You can coordinate wise, you can write 16 minus 9 comma 5. Yeah. So this is how you would do. And without computing, actually, what can you tell me about A cross A?
It's
You
0.
don't have to. How?
Like if we try to visualize it in the form of the determinant itself, then two
Mm-hmm.
rows become equal, and if we
No.
perform a row operation, we can convert one row to 0 completely. So it's the answer is 0.
Okay, but without you are actually using the computation then without actually computing. Can you tell like can you use certain identity to say that?
Again,
Okay.
if I also use the formula,
Mm-hmm.
uh, like a cross b, the value of it is a into b into sine theta, where theta is the angle between them, and n cap. And sine 0 degree is 0. So even in that way, we get it 0.
Sorry, are you saying this?
Yes, ma'am.
Okay. Then this is nothing but 0. This is another way, yes. One more way which I want to say is use this fact that how A cross B and B cross A are related. Are they related?
Yeah, a cross b is minus b cross a.
Yeah. And this is true for all AB, right?
Yes.
What if I put A to be B? So A cross A is just minus of A cross A. It would directly give me A cross A has to be 0, no matter what A you choose. Alright, so this is certain simple facts. You may also compute what is A dot A cross B. That you can also do. You can quickly compute that.
That would be 0 as well.
That would be 0 as well. And why so?
Like we can exchange the cross and the dot here. So it becomes a cross a dot b, and a cross a gives us 0 directly. and
Sorry,
0 dot
sorry.
anything is 0.
Just a moment, just a moment. You are being fast. Just give me a time. Okay, this is what we are trying to compute. What did you say then?
So I'll exchange the dot and the cross and transform it to A cross A dot B.
Very good. So these two things you know. If you know this, then you know that this is also zero without even computing. Very good. So use this fact and then directly you can say it is zero. So this answer is also zero. This answer is also zero. All right. So let's go now. What is cross product? Somebody asked me what is the meaning. So if you see here in this figure, this is one plane I have drawn, and in that we have chosen two vectors A and B. If you see the way A cross B has been written, it is nothing but it is a vector which is perpendicular to the plane generated by A and B. If you have A, if you have B, you can very well made a plane out of those two vectors. And the plane which has been spanned by those two vectors, you have to just take a vector which is perpendicular to the whole plane. And for this, if you want to realize some idea I can give you. So the way sir was saying in the lectures, it is like you are rotating a bottle, and wherever the tip of that bottle will in the direction wherever the tip of the bottle is, that will show you the direction of your vector which is perpendicular to the plane. So you can also visualize this fact by, suppose you are having two vectors and you have seen right and thumb rule. It is kind of the same thing, because if you suppose you have two vectors where you can point the first two fingers in those directions of those vectors, then if you want to write A cross B, then you have to curl your remaining fingers from that vector to the other remaining vector, and the direction of your thumb somehow will give the direction of the normal vector, and normal is the vector which is perpendicular to that, to both the vectors. So roughly it is the basically, if somebody wants to know what is geometrically cross product, it is
Hello. Ma'am, you are not audible at this moment.
Hello?
Yeah, now you're audible again.
Okay, okay. I'm sorry, Wi-Fi was not working. So, how much did you hear from this part? I was saying about the cross product.
Yeah, it was audible till the time you said about the screw analogy.
Sorry. Okay, let me repeat. So, A cross B. What I want to say here is it is nothing but you take two vectors A and B and then generate a plane from those two vectors. And what you have to take A cross B is nothing but a perpendicular vector, which is not just perpendicular to two vectors, but the entire plane generated by those two vectors. So if you see in this diagram, this A cross B is nothing but the normal to the plane generated by A and B. And of course, B cross A is in the negative direction, so you can see the negative of that vector. And somehow, if you want to see it roughly, then I would say it is using right hand thumb rule, where you take these two vectors A and B by pointing as your first two fingers represent your A and B, and then you have to curl your remaining fingers from one vector to the other. Suppose I want to take A cross B, and A is your the first finger, B is your second finger. So remaining two fingers you have to curl from A towards B, and the way you are curling, the direction of your thumb somehow will give you the normal direction, which is perpendicular to the somehow the both the vectors, not just that, but the plane generated by that. So roughly, I would say that you can compute the normal vector through right hand thumb rule. You just have to see your vectors by first two fingers and then curl the remaining fingers from one vector to the other. Direction of normal will be given by thumb somehow. This is what how I understand it. And geometrically, if somebody asks, you just have to say that A cross B is nothing but the vector which is perpendicular to the plane which is spanned by both the vectors A and B. Is that okay?
Yes, ma'am.
Okay. Okay. Another question here is I have drawn a figure and you have to tell me the area of that shaded region where these two vectors I have written. What are those? A and B. Can you tell the area of that shaded region? First of all, is this shaded region somehow known to you, the figure?
It's a parallelogram.
It's a parallelogram. Very good. Then can you tell me the area of that parallelogram? If you carefully look at your lecture notes, I think somewhere it has been told.
Yeah, we'll take the cross product of the two constituent vectors.
That's all. But cross product is again a vector.
And then we will take its norm of the
Right.
resultant vector.
Correct, correct. So if you want to see, can you tell me quickly how do you see the area to be as product of that? I mean the norm of that A cross B. So notice that. By the way, is the recording still going on or happened to the recording? Yes, recording is still going on, I think. So notice that the if you take norm of the cross product is a vector, and then you can talk about its norm. This is nothing but the area of parallelogram formed by. Okay, can you quickly see the proof? It's not very difficult, I think. Now can you see?
Yes, ma'am.
Okay. So do you prefer to find here? There are two figures here now.
The rectangle is easier.
Yeah, rectangular one is easier. Can you tell the area for the rectangular figure?
Like the formula is based into or the length into breadth.
Okay, but can you tell the length and the breadth? This is the only thing which is left, right? Okay, knowing this is norm B, do you agree that this length of the vector B is nothing but the norm B?
Yes.
Can you tell the vertical line which I have drawn in the sky blue color? Can you tell the length of that? Isn't it perpendicular? They're projecting that. So can you tell now what is the length? If you remember, this length is nothing but b cos theta, and this is nothing but b sine theta, right? So this
Yes.
length is also b sine theta. And if this length is a, because it's a parallelogram where one has length a, one has length b, then the rectangular, this part also has length a, right?
Yes.
Right? So now can you tell what is the area?
A norm A into norm B into sine theta.
And what is this?
It is the cross product between A and B. And the value of the cross product.
Right. So therefore, you just simply have to compute, and this is nothing but the area of rectangle, but this is same as the area of parallelogram. Finally, you are good with move across the. Is this okay? A cross B.
Yes, ma'am.
Now, what is the norm? That is easy, right?
The root of 17 square plus 17 square plus 17 square.
So, and this is okay. So, this is how you will find the area. If somebody gives you a parallelogram and you know the vector which generates the parallelogram, then it is just the norm of the cross product of those two. It's as simple as provided you know that how to compute that. All right. So that day we somebody also asked me what is a geometric interpretation of dot product. So here is that. Okay. Suppose we have one vector b. I'll try to show you. This is one vector b. Another vector is a. What we are searching here is a vector which is perpendicular to the vector b. So of course, by figure you can say that it is certain vector of this form, then only it will form a 90-degree angle with that. But what I want to say is, suppose I have a point P on the line B itself, on the vector B itself. Then you very well know that if this is P, this is A, then what is A minus P? It is exactly this, right? This is because of um, your parallelogram of addition or subtraction, the way you say, anyway. So it is A minus P. Now, but clearly P is a vector which I have chosen is on the vector B itself. So what I am trying to find here is a vector P which has to be certain multiple of your B, C times B for some C, such that if I take A minus P, then it should be normal to B. That means the dot product of A minus P with the B has to be 0. But we are trying to find, is there a way? Can we do that? So assume that there exists a point P such that this A minus P is perpendicular to the line, the vector B. That means it should satisfy this condition that A dot B is same as P times B dot B. And from I can very well write what is C. That means C is uniquely determined. That means the projection, CB is nothing but the projection, right? If I see the projection of A, if I project my A along B, then this is nothing but that point which is perpendicular to your vector B. So this is how we say that CB is the projection of the A vector along the direction B. Is that okay? Like the way we are calling CB? Okay, assuming that this is fine. Now, suppose this length is CB and you know by trigonometric ratios, if this length is A, then this is very well length A sine theta and this is length A cos theta. Now here, knowing this length is also CB and this is also equal to A cos theta, can you tell what is C or cos theta here? What is cos theta here?
The length CB divided by the norm of A.
Right. This is exactly C tan B by A. Now, using all these facts, can you tell me what is A dot B?
Could you repeat this portion from the beginning?
Okay, sure. So, suppose I want to find a vector um, which is perpendicular to B and which I have to project through A. Okay, I want to project A in such a way that the vector which I project on B that becomes perpendicular to B. Okay, if I project a vector like this, it is not perpendicular, right? If I project a vector like this, it is not perpendicular. But what we are searching is a point P such that if I project my A to that point P on B, the point becomes perpendicular to that line. The projection becomes perpendicular. That means the angle should be 90 degree, not any other angle. So clearly this point which we are searching is on the line in the vector B itself. Therefore, it has to be certain multiple of B. It can be half, it can be 2, it can be anything like some scalar which we are trying to compute. Yeah, we don't know that. What is that? So if such a point is there, what is the meaning that the dot product of A minus CB and B has to be 0? Is that okay? They are perpendicular, that means dot product is 0. Is that okay?
Using the constant C, we are basically scaling D, right?
We are basically scaling, yes. Of course, if suppose I tell you this length is 4 and suppose I tell you this length is 3, what is that scalar? Can you tell me?
3 by 4.
Right. So it has to be some scalar time that length of the B. This is what I'm saying. Is that okay?
Yeah, I'm not getting this part. How is A minus CB dot B equal to 0?
What is A minus P? It is that vector, right? This vector is A minus P and this is perpendicular to the vector B.
Okay.
Right. So one vector is A minus P, another vector is B, and clearly the angle, if you see, they are 90 degrees. This we are finding, like what P is there. That means the dot product of these two vectors should be 0. But P is nothing but C times B, right? So therefore A minus CB times B has to be 0, and that would give me C is A dot B by B dot B. Is that
Okay.
fine? Okay. Now from here, knowing all these facts, we got cos theta as C times B norm B by norm A. We also know what is C. Now here, from here, can we tell what is A dot B? So here I'll just write. I might be confusing few things. So from here, C cos theta is CB by norm B. But what is C? It is A dot B by B dot B by norm B. This is okay, right? Sorry, it
Yes.
has to be, uh, it is the length of B, right? P plus C times length of B. So this has to be norm, sorry, it has to be norm. So from here, you see this is norm square, and you will get that A dot B, there is a norm A here, and just simply put the value of C. Norm B square, norm B, norm A is cos theta, and A dot B is norm A, norm B, cos theta. Is that okay?
Yes.
So I'm just giving a proof that how A dot B is norm A, norm B, cos theta. Now can you tell what is this C? And now can you also tell uh, what is this, what do I say? The, basically the meaning of the dot product. So here we deduce that A dot B is nothing but A norm theta. What is norm A cos theta and what is norm B? So if we see this is our norm B and this is our A cos theta. So it is nothing but the product of the vector B, the length of the vector B, with the length of the point P, from which is nothing but the projection of A to P. Right? So geometrically, the meaning of dot product is nothing but it is the product of lengths of the vector B and the vector which is um, projection of a given vector A to the vector B. Is that okay? Does it make sense? Okay, let me highlight once again. So A A dot B, we got A cos theta into B, right? I'm just writing AB cos theta as this form. What is this length, A cos theta? It is the
It's the
length of
length
OP, right?
OP. Yes.
And what is the B? B is nothing but the vector which we had. And what is OP? OP length is nothing but the length of that vector which we have projected from A along the length B, right?
Yes.
So it is basically the product of the vector B and the vector which is nothing but the projection of vector A along vector B. I
Okay.
hope it is okay. So it is dot product is nothing but the products of two lengths where one vector is we have to determine. This is nothing but the projection of a vector A along the vector B.
So let's say A dot B would be like
Mhm.
multiplication between two vectors, one of which is projection of the first vector on the second vector, and the other is the second vector itself.
Hello.
Hello.
I'm sorry. Yeah, I can hear you. Can you please repeat what you were saying?
Well, so the A dot B would be the product between two, like the magnitude of two vectors, one of which is
Mm-hmm.
the projection of the first vector on the second, and the second vector is
Mm-hmm.
that vector itself.
Right, right. Exactly. So it is product of lengths of two vectors. One is the vector itself, another is projection to that vector. Yes. All right. I think now you understand what is a geometric interpretation of dot product. All right. Let's see one more question. So we have to write a parametric equation of a straight line passing through a point P in the direction of A. You see direction of our point A is has to be this. This is why I have written the straight line in this direction. Point is this. Point is this and the direction is this. Can you tell me the parametric equation? Suppose two lines are parallel. If I look at the difference of the 2 points, suppose this line is parallel to this another line. If I take 2 points, can you tell the difference of those 2 points? Any
The difference would be equal everywhere.
it has to be certain scalar, right?
Yeah,
So here also, this line, if I try to draw a line, okay, these two lines are parallel, right? Because we are fixing one vector and then we are saying we are parallelly drawing one another line whose point is P, but the direction is same. Direction means they have to be parallel, right? Now, saying this, that means you are just translating your line by certain number. If you see, so if this is line y equal to mx, if you are passing through another point, then you will translate that, right? So that it will not pass through region, it will pass through some other point. Is that okay?
yes.
So this is what we are saying. The direction is A and the point is minus 2 comma 1. Can you write a line equation of line? So if, let me tell you. So suppose my point is x comma y. Any point is on the line. This is on the line. Then what is the meaning that this it has to pass through point P in the direction? That means the point has to be minus 2 plus translated by the direction minus 1. And T can be anything from the real line R. And same thing, the y coordinate, which has to pass through 1, but it has to be translated by the direction which we are writing 5. Is that okay? If I take t to be 0, the point will be minus 2, 1. That means my point on the line is minus 2, comma 1. That means we are passing through minus 2, comma 1. And if I write any t, that means we are translating that line which was passing through minus 2, comma 1, but by the direction A. Is that okay?
So,
Suppose you
like
have any
the
point.
parameter t just represents how much we have to translate the original line to get the new line.
Well, you can see that. Let's say, let me write this. Okay, if I try to write two lines, can you tell suppose I tell you this is 1 1, this is 3 3, and this is 0 1, this is 0 3. If I ask you writing an equation, how they differ? They will differ by a scalar only if they are parallel. And that difference here is taken care by t. Is that okay? Does it make sense?
Yes.
So if you have any point, let's say PQ, you want to pass through this point, but you want to make sure your direction of the line, because if you want to, suppose your point is this, your line can be this, your line can be this, your line can be this, but fixing one direction, suppose this, that means your line has to be this only, right? If I direction, that means this has to be the correct choice of the line, right?
Yes.
So what we do, you just simply take this point P comma Q and translate it the direction, whatever direction you want. Your vector is, let's say, A comma B. It is just translated by that. Is that okay?
Yes.
This is how you will get all points. So you can just simply write your vector x as your coordinate x as p plus t times a, and then y is q plus t times b. This is exactly we are doing, right? All right. So I hope this concept is okay. Now another thing is volume of the parallelepiped spanned by these three vectors. Can you tell that? This also has been discussed in the lecture class, I think.
We do it using the scalar triple product.
Right. So if I have A, B, C, which scalar? How do you write?
Like
Is
it's
it
A
A dot B
cross
cross
B
C?
dot C. Like it could be in any order.
Okay, A cross B dot C. And then?
And like this will give us a scalar value itself because we are evaluating
Right,
dots.
right. Exactly, exactly. So this itself is the volume of the parallelepiped. So I'll just, shall we compute it or what do we do? Let's compute. What is A cross B? So recall.
The answer would be minus I cap plus 7 j plus 4 k cap.
Okay, what is I cap?
Minus I cap
Mm-hmm.
plus 7 j cap
Mm-hmm.
plus 4 k cap.
Okay, let me see. Right. So, okay, this is A cross B. And now can you tell what is the volume?
So we will basically just take the corresponding coordinates
Mm-hmm.
between A cross B and C and we will multiply them.
Okay, let's look at A dot. This is A cross B coordinate, and what is the coordinate to 1, 2? What is that now?
And then we will add the
Okay,
answers.
finally, what do you get?
We get 9.
Right. So it is minus 2 plus 4 plus 7, which is 9. Okay, so therefore we got the volume of the parallelepiped. So whenever volume of parallelepiped or area of the parallelogram comes, the very first thing you should remember that it can be computed by cross and dot products. You don't have to go finding actually volume by geometric or any other way. All right, so there are some more questions. So give an example of a function from R to R which is continuous but not differentiable.
Y equals to mod x.
Okay, y equal to mod x is 1, yes. Any other? And where is not differentiable, by the way? Is it differentiable at all
It's not
points or?
differentiable at x equal to 0.
Yeah, so it is not differentiable at x equal to 0. And what is the issue?
Like it forms a sharp corner
Okay,
at
this is
x.
one geometric way to say, yeah. But how do you prove that it's not differentiable?
Like the left hand derivative and right hand derivative will not be equal.
Right, so what left hand derivative is nothing but, can you tell quickly at 0?
So left hand derivative would be -1, right hand derivative would be +1.
Exactly. So since they are not equal, therefore function is not differentiable. And what about other points?
At other points, it would be continuous and differentiable.
Right. So the issue is only at the zero and which is not differentiable. Otherwise, it is differentiable. Right. So another question is we have to just not find the function on R to R, but R2 to R, which is continuous but not differentiable. Can you help me now writing that using this uh, function on one variable?
Um, we can try x square y by x square plus y square if
Mm-hmm.
xy is not equal to 0 and 0 when xy is 0.
How would you say that this is not differentiable and where it is not differentiable?
It's not differentiable at 0.
Why? First of all, we want yeah, no, correct. You're
Wait,
saying
zero.
correct.
0. Um,
How did you construct it so quickly, this function?
memory, I believe.
Sorry?
Memory.
You memorized it.
Like I know the logic, but I forgot how to do it. Like
Okay.
since in at the multivariable level, like in
Mm-hmm.
3D, we do not have left side and right side. So we have to
Uh-huh.
approach from any side,
Mm-hmm.
and in that way we have to do it. There's no left and
Okay.
right in 3D.
And
That's
how do
why.
you write that? Suppose in here, what we write is limit h tends to 0, f of h minus f of 0 by h. Here, how would I write? If you recall the derivative, the definition of the derivative, if suppose function is differentiable at certain point, what is the derivative of that function then?
Um, uh,
Is it a scalar?
no, it's a vector.
It's a
It's the
vector.
gradient.
It's a gradient. Very good. So in function on one variable, you have the derivative at a point is scalar, but for higher dimensional, your del f at 0, 0, let's say, this is nothing but the if at all function is differentiable. So this is nothing but the derivative of the function at 0, 0. And how do you compute the gradient of a function?
It's the just the partial derivatives of the dependent variables,
Right.
independent
So it is the
variables. So
partial
yeah,
derivative of this. Okay, in order to say that this exists, if you have, if you can argue that the partial derivatives do not exist, will that be enough? If at all function is
yes,
differentiable, the gradient has to be of this form. But if you do not have partial derivatives, how do you write your gradient?
we can't.
You can't. So can you say now that certain thing will not exist and therefore function is not differentiable? Yeah.
Okay.
So what is the definition of derivative of x at this? Can you tell me quickly the definition?
Limit h tends to 0,
Hmm?
f of uh, x minus h
X
comma
minus.
y by minus
Here x and
h.
our points are 0, 0. Is that
Yes,
okay?
Yes.
Now can you tell me this limit?
Zero.
0. And what about this?
That too will be zero, I believe.
That will also be 0. Limit f of 0 comma k minus f of 0 by. That is also 0, right? So certainly you cannot use this fact because limit exists. And
Yes.
therefore you cannot simply say that what are these. Um, but I think later you will see that this partial derivatives, not just they have to be differentiable, they have to be continuous also. And you can prove by that fact, which you have not seen now, that in order to say function is differentiable, this is just a necessary condition that partial derivatives should exist. This is not sufficient. So you have to somehow look at the derivative, partial derivatives, and look at whether they are continuous functions or not. So I think this example for right now, since we do not have much things to say how to say it's not differentiable, let's look at simpler example. What if I say f of x comma y is just mod x? Now can you say is it differentiable? I can write this function. Is that okay? Does the partial derivative exist at x? Hello?
Hello.
Yeah, am I audible?
Yes, ma'am, you are audible.
Can you check this function? Is this okay?
The partial derivative with respect to x will have different values
Yeah,
for
but limit.
x minus x, and in case of y, it will be zero altogether.
Right. So, but you cannot write the partial derivative at 0. Suppose I want to check the function differentiability at 0, 0. Does it have partial derivative at 0, 0? What can you say about del f by del x at 0, 0? Does it exist? Hello?
Yeah, ma'am, you are audible. We are confused, that's all.
Ah, okay.
Ma'am, are you there?
Sorry.
No, I thought you were disconnected.
Okay, so let me just quickly tell. So there are two examples which I'm here telling. One I gave you, and another is this. You check whether they are differentiable or not. Y is not equal to x square, and then 0 when y equal to x square. Okay, and what do you feel? Is it differentiable or not? So your function is given along one path. Okay, we are fixing one path y equal to x square. Is it this is what kind of path? Can you tell me what is this? Y equal to x square is the curve known to you? Is this a parabola, a synchrorigin? Hello, are you people with me or what happened?
Yes, ma'am, we are there.
Okay. Are you confused with certain thing or what? I'm not getting exactly why are you quiet.
Ma'am, repeat this part which you did.
I'm just writing that this curve, is it okay? Y equal to x square is the curve parabola or no?
Yes, it's okay.
Yeah, so I'm telling that this is one function and check that f is not differentiable and the issue is at 0. Okay, and another thing here important is that function is um, this has all partial derivatives. Just note that f has all partial derivatives exists at this point. So you cannot argue through partial derivative. You have to argue through the definition itself. Okay, so this is one example. Another we saw. Okay, let's check. Otherwise, I will discuss this in the next lecture. So it's a small homework maybe. Okay. Um, so let's find the limit of these following functions. We have any functions and you have to find the limit. Can you please try the first part? Limit xy tends to 0, 0, x square minus y square by x square plus y square. Maybe just a small hint. If you want to check this, you have to use the definition that f of xy maybe of xy minus f of x naught y naught and minus um, the gradient of f at x naught y naught divided by sum of x naught x minus x naught y minus y naught. This tends to 0 as xy tends to x naught y. You have to basically use the definition. All right. So what about the first limit? Is this limit exist or if it exists, what is that limit? So you have to approach the point 0, 0, and as sir said, you can approach in many ways. So in all the ways, the limit value has to be same if it at all exists.
It would be better if you show us how to do this one.
Okay, sure. So suppose I approach towards this y equal to 0. Hmm. So y equal to 0 is which kind of path? This is this path, right? I'm approaching towards x-axis from the x-axis, let's say both the side to the point 0, 0. Is that okay? So this is
Yes.
one path. So fix a path, fix y equal to 0. Then I'm approaching to this and the function will become x square by x square. What is the limit?
1.
1. But what if I approach by another path? Let's say x equal to 0. Right? So I will simply write fix x equal to 0. Then try to find the limit. Can you tell me the limit now?
-1.
This is minus 1. Can it happen if the limit exists?
No.
Yeah, so here you would say that, okay, let me just shift all this to. So here you would say that since uh, by different paths, by choosing different paths, we got different limits. Therefore, limit does not exist. This is okay, right? You will simply cleverly you choose, look at the function carefully for a minute and see which path will be very useful for you to choose so that you can somehow prove that this is the limit does not exist. For limit does not exist, you have to choose paths.
Okay.
Okay, yeah. So if you understand, then try looking the part B, if at all you can do here something. You see, if I can choose, there is some background noise. Can you please, yeah. Uh, okay. So if you look at the function carefully, so this is kind of homogeneous polynomial. The degrees in the numerator and degrees in the denominator are same. That means somehow you can cancel your degrees and look at, you can get a scalar. You see? So possible choice, suppose I choose a path, y equal to x. Can you tell me the limit?
Yes, we can do it.
Yeah. So look at the function carefully and look at what path. Here y equal to 0, x equal to 0 is not at all useful. You have to use some other path. People choose the straight line path. So if you see y equal to x, this is this line. If I say y equal to 2x, this will be this line. If I say y equal to minus x, something this line. You have to choose certain paths to approach this. Now, I have given you plenty of lines. Can you choose two lines such that it takes two different values?
Like y equals to x will give us 1.
Y equal to x plus.
No, 1/2 it will give us.
Okay, y equal to x. Choose the path y equal to x. I think this line is y equal to x plus certain constant. This is y equal to minus x. Okay, so this line will give you limit x tends to 0 y you have replaced in terms of x square by x square plus x square. I think I'm here. Yeah.
And if we take y equal to minus x, we get it as infinity.
Yeah. Oh, really? That extends to 0 minus x square by x square plus x square. How are you getting
Actually,
infinity?
no. Okay. Yeah, it was a square in the denominator.
Yeah, I'm telling it is homogeneous. This is how I'm doing that, so that it will get cancelled. You see, when degrees are same, so the mostly the straight lines are going to help you. So you can very well write like this. Let me tell you how to write such questions. So how to choose the paths. So here, right, choose any y equal to mx. This is any straight line passing through origin. Okay. Then limit of limit x tends to 0, your function will become mx square by x square by m square x square. You can very well cancel x square and you will remain with this. This quantity limit is just simply the same number, right? And here you can say, depending on m, limits are many, infinitely many in fact, but it cannot happen. So therefore, again, this function does not, the limits does not exist for this case. Do you agree?
Yes, ma'am.
Yeah, so this is how you have to very carefully choose the paths and prove that two limits are different and you are done. All right. I think I have to go back because I deleted one of this. Huh. Okay, now I think you should. I am not able. Let me write again if such. X square by x square 1 plus m square. This is m by 1 plus m square, and since m varies, if m varies, limit also varies, and this is certain kind of contradiction, therefore limit does not exist. Yeah, I think this is okay. Now the remaining question. Now you should be able to do this. What about third part? Hello?
In the third part, limit will exist, I think.
Yeah, limit will exist, that is for sure. This is how, since you have carefully seen the function, yes, because it is not kind of homogeneous, okay? So, yeah, limit exists, but this time you have to prove. And what is your guess? What is the limit for, by the way? If it is existing,
Like in this case also, if we take y equals to mx,
mm-hmm.
then at the end we will get m by 1 plus m square into
No.
x.
Okay. M by 1 plus m square into x. Yes.
So the value will depend on x. And since we are checking at 0, in every case the limit will be 0 only.
Yeah, but this is not just one path. Somebody can choose this path. Somebody can choose, let's say, this path. Somebody can choose this path. Who knows? But saying that limit exists by paths, this is not the idea. When you have to prove certain limit, you have to prove by definition. Now you know that ultimately if limit exists, it has to be 0. You know it. But you have to prove that the limit is this. So if you remember the definition, that when do we say function has this limit? Do you remember the definition? So let me recall. We say limit x y goes to x naught y naught f of x y. If this is L, then what do we say? Given any epsilon small enough number positive, there exists a delta. Of course, it depends on epsilon, such that, again positive, whenever the distance between your point and the limit is function limit is less than epsilon, the distance between your point and the limiting point has to be less than delta. If the distance between xy minus x naught y naught less than delta. But how do you find the distance? It is just simply x minus x naught square plus y minus y naught square. So what do you have to do? Whenever this term is less than delta, you have to prove that this term is less than epsilon. Yeah? So let's prove this. Okay, let's prove. Since you know the limit has to be 0, this is your guess. Let's prove whether this is true or not. So what do you have to prove? Given epsilon positive. So let's take epsilon positive. You have to prove that x square y by x square y square minus 0, 0 is the limit. This has to be less than epsilon whenever this distance, but x naught y naught is 0 here, so I will simply write x square plus y square less than delta. Is that okay? So x naught y naught is 0 for our case. From here, I'm getting this. So whenever this is there, this is what I have to claim. Assume that this is given. Now, look at carefully your numerator and denominator. Somehow the numbers are quite related with whatever we are having here. If you see highlighting this number and this number, they are related. Similarly, you can relate this number with this. Let's see how to do that. You know, this quantity I can very well write as x square times mod y by x square plus y square. Yeah, modulus I can write that. Can you tell me, can I write this strictly less than mod y? Can I write this? Is this inequality true? Sorry, strict inequality. In order to say that, look at the numerator x square by x square plus y square. Can we say this is less than 1?
Yes, we can.
Yeah, it is very simple, right? Because unless your x and y both are 0, these two quantities will always be positive. So I can simply write them equal to x square by x square plus y square. And this is always true, right? X square is always less than x square plus y square. It can be equal also, provided y is 0. But we are not assuming that. Or if you want to assume, we can assume that also. So let's assume that also. This is equal. Assume that also. This is okay, right?
Yes.
And this is true. Now, can I use this fact? Let me highlight. Can we use this fact to say this is less than epsilon? How do you relate this quantity and this quantity?
Wait, just repeat how we had written that one.
Okay,
This
okay, okay. Let
this
me,
part
yeah,
less than equal to y.
less than equal to y. Yeah, yeah. Let me repeat that. So here, This I can write this. Is this okay?
Yes.
If I can write this, can I write this?
Okay, okay. Got it.
Yeah. Okay. So finally, we got this inequality. Now, unless we use that fact, there is, how do we write then? We are writing this because we will be using this part somewhere. So what we are assuming, whenever this is true, I should be able to produce an epsilon here. Hmm. Now, you have to somehow use this. That means you have to relate this quantity and this quantity. Can you do that? Notice that if you want to relate mod y and x square plus y square, no. The most obvious thing what you do in order to relate these two things, very
We
first
can
thing,
square both sides.
square it. Very good. Now can you relate?
Yeah, left hand side is less than right hand side.
Can you say here also?
Yes.
Okay, very good. Now therefore you can simply say that this is less than equal to under root x square plus y square, which is less than delta. Strictly less than delta. Can I choose delta to be epsilon only? Are we done?
Yes, we can.
Right, because delta is also very small enough. Because what we are saying, whenever the distance between the 2 points is less than a very small number, delta is also very small, then the distance of the function value with the L has to be very less than small, even less than the epsilon. So therefore, delta will work as an epsilon very well because it is also a small positive number. So right, finally choose delta is epsilon, and finally I'm just concluding that what we got is x square y by x square plus y square minus 0 is less than epsilon whenever x square plus y square is less than delta. We have very well used this property. Now, just using the definition, we got that limit is nothing but 0. Is this okay?
Yes.
So, proving limit is bit difficult than proving that limit does not exist. It's difficult because you have to play with the inequalities. Hmm. All right, so I assume that you got some idea. Now let's do fourth part. It should not be difficult. Remember what kind of function is that? Look carefully, then you will get it.
Homogeneous function.
Yeah, it's a homogeneous function. So quickly look at certain paths, I think you'll get it.
Yet limit will not exist.
Yes, limit will not exist. Very good. Answer is, let me just copy these two things on next page. Cut it. Yeah. So how do you argue? Can you tell the proof also? Solution? It does not exist.
Yeah, for this one also we can assume y equal to mx as the path,
Yeah.
and after substituting, if we solve,
What do you get?
the final term would be m minus m square by 1 plus m square.
Yes.
And so the limit will vary with whatever path we are choosing.
Yeah. So if you choose your m as you want, as many m you choose, as many values you will get. Again, limit does not exist. Very good. So can you say, what can you say quickly about 5, part number 5? This is also easy. Here things are quite straightforward. So assume you are taking limits going to 0. Suppose you directly put those limits to your function. What will happen? Yeah, where will this function goes if I put x and y both tending to 0?
Okay, it will be minus 5 by 2.
Very good. Here there is no ambiguity. Why? You know, earlier if you see the functions, each time you have a denominator, 0 by 0 form. You cannot argue anything. But here you can directly say whatever path you choose, you anyway go to 0, 0 and put that function values to be 0, 0, you will certainly get this value. Okay, so this is simple to say that limit is minus 5 by 2. Okay, so limit is minus 5 by 2. Good. So yeah, let's look at certain derivatives now. We have to find the derivatives of these compositions of various functions. Part A. Y is sine composed with cos composed with x square. There are two ways to see it. Either you define your function as composition of functions and use the chain rule, or I mean, anyway, you have to do that way only. But how many functions would you write as composition of these y? It can be 1, 2, 3. Suppose let's solve this, huh? Let's solve this. Solution. Y is sine of cos x square. Yeah, if I simply put z to be cos x square, that is a function of x now, and y is a function of z now. Can you tell me now? Now we are in the situation of composition of two functions, yeah?
Yeah.
So you can very well write y as a function of z is a function of x. Therefore, let's say this capital Y or same Y, I think, f of z, this is nothing but f of g of x, right? This is your Y.
Yes.
Now, can you use some rule? Yeah, we have certain rule for this.
Like we can first find dy by dz,
dy
and then we
by
can find
dz.
dz by dx, and if we multiply them, we get dy by dx.
Okay, are you saying this?
Yes.
Good. So tell me, what is this?
Dy by dz will give us cos z,
Yes.
and dz by dx by chain rule will give us minus sine x square into 2x.
Okay. You still want to make sure if another function you can simply put one more thing, but I am not making that complicated. So I think it is okay. Now you
And now we
but
resubstitute z for its value.
very good. Cos of cos x square, then 2x, then sin x square. Okay, good. So you have used the chain rule, I think, and you have used this property. Okay, you can directly use here also. Let me write in the red line that y prime x, which is nothing but this, is you using chain rule. It is f prime at g at x times g prime x. Now, if you want to write that, what is your f prime at gx? It is simply cos of cos x square. And then g prime x is nothing but minus a sin x square into 2x. So answer will be same. Either you use this or you use this. It is same thing. Let's look at another function. W is, so this is my function. W is a function of x, y, z. And x are the functions of t. X, y, z, they are functions of t. You have to finally find the derivative of w with respect to t. There are two ways to do it. Can you do it?
I'm trying.
Hmm.
We can substitute the values and we can try it in that way.
Yeah, this is one way. This is one way. You substitute of x, y, z in terms of t and write your function in terms of t directly. Okay, so let me try writing this way which you are suggesting. Paste here. So w is a function of x, y, z, but I can also write very well as a function of t as t cos sine inverse. I think this is okay. One way is you directly differentiate it. How do you do that?
The sine inverse t can be converted to cos inverse root 1 minus x square. 1 minus t square.
Oh, okay, okay, okay. What are you doing? Sine inverse is nothing but
Cos inverse 1 minus t square.
1 minus t square. Okay, how do you
Under root.
Ah, okay. Sorry, tell me, how do you see that? Am I missing something?
So if you substitute that, then we will have t cube into 1 minus t square.
No, no, it's okay, but how do you write this? Sorry, I am not seeing that. Is there any identity for this?
Then what did you ask?
Sorry, how did you see this? I bit confused. Is it some identity?
Yeah, it's an identity.
Ah, okay, okay. Sorry, I don't remember identity. So, all right. Suppose we know this. Suppose I assume this. Then what is the derivative? This is my w. If you have product of two functions, how do you find the derivative?
We use the uv rule.
Yeah, you
u,
keep
u dash v plus uv
right.
dash.
To keep one as constant, take the derivative of other. So 3t square 1 minus t square plus t cube 1 by 2 under root 1 minus t square and then minus 2t. I think this should be okay. So 3t square 1 minus square minus t4 by 1 minus t square. Yeah, is that okay? 3t square 1 minus t square by under root 1 minus t square minus t4. This will be 3t square minus 4t4 by 1 minus t square, and I think 3 minus 4t square times 1 minus t square. Is this okay?
Yes, it's okay.
Okay. So either you do another way. Can you tell another way? This is very complicated in the sense like you have to keep putting and then finally find the. You can use the chain rule. This is what I want to say.
I can't think of the other way right now.
Okay. Any other student? You are the only, I think, replying to the questions. No, nobody else is replying. So let me write again. W is function of x, y, z, and the function is x, y, cos z. Then x is t, y is t square, and then z is sine inverse t. Yeah. So in principle your function is function of x, y, z only, but you want to compute this. So you know what is the derivative, the gradient of w. If a function is there, you know what is the gradient of that. And what is that? It is the partial derivative with respect to x, with respect to y, with respect to z. Is that okay?
Yes.
But your function is somehow, it's a function of x, y, z. So finally you have to write the gradient equal to, what do I want to write here? I'm also confused in some sense. Is a function of x, y, z, yeah, and x is further a function of t. So you can just to say same thing. Dx by dt, dy by dt, and dz by dt. Sorry, I am a bit confused. Let me write the general phenomena. If your function is nothing but another variable uv, here we have three variables, let's say u, v, w, and your function u is another function of, let's say, xy, v is function of xy, g is function of xy. So then the gradient is nothing but del f by del u, del f by del f by del w, and this is nothing.
Ma'am, you are not audible right now.
Can you hear me?
The voice is faint and kind of distorted.
Yes, just give me a minute. Is it better now?
Now it's better.
Okay, let's go back. And what I want to say here is this: x is a function of t. So maybe let me. I'm also getting confused here. Huh. This your function del x. Huh? Okay, del w by del x. This you can write del w by del x into x is a function of t. You can very well write this by this, right? Sorry, am I doing some mistake? It should be t. Same thing, del w by del t can also be written by this form. And same thing can be written as this. So your w is nothing but a function of, if I write my, let me write f to be x, y, z to be x, g, x, y, z to be y, h, x, y, z to be cos z. Then W is nothing but F compose. The way the variables I think I have chosen, it's not that good. Let me write. Okay, I think let's do some other example. Here I am also getting confused. So I think one way we know. Let
Like in
me
the
do
part
another.
where you wrote, where you divided into three parts, like del
Mm-hmm.
W, we can solve that part, that partial
Well,
derivative which you wrote.
you know, I want to write my function as composition. I want to use chain rule, but how to write that? W is x, y, cos, z. And I want to write it as a composition of function. So I think the variable, the way I have written, it's making me, confusing me. The x, y, z are not they are functions, they are further functions. So maybe let's look some other example. Okay, let's do some other example where the things are not that difficult to see. Yeah, here let's say. Let's see this part number C. Okay. You look, you see, this one can do like this. So your gradient of f is nothing but the way it has to be. It is composition of f composed with x. X can be written as a function of, yeah, this is correct way I think. So w is nothing but xy cos z. It's a function of x, y, and z. But your x is further function of t. Y is a function of t. Z is a function of t. So you can very well write W as composition of functions, right?
Yeah.
So then you will be having X compose G, sorry, F compose G, comma H, comma K. Yeah. So here you have to say like this. You have to, am I still confusing? I think I have to make one more function, K prime T, which is nothing but gt, comma ht, comma kt, and then w is nothing but f compose k prime. Yeah, I think this is okay. So then w del w by del t is nothing but uh, your this function, your f, and then k prime. K prime is nothing but g h k, but with this is nothing but you have to take the derivative of those, but they are not nothing but gt is nothing but x, so dx by dt. Ht is nothing but dy by dt. Kt is nothing but dz by dt. So finally, your del f, which is df by dt, it is the product of these two, del f by del x, dx by dt, del f by del y, and del f by del z. So I think this is one way. It's bit confusing in the sense you have to write the function in a way it looks like a composition. That is the only thing that you have to do. Otherwise, you simply put the values and to take the derivative. This is another way. So I think this is okay now. Let's look at how to do this. Okay. Let's assume that this is okay. Then write the derivative. F is x, y is cos z, and x is nothing but t. Y is nothing but I think y is nothing but is y t square sin inverse t. Now use the formula del f by del x. If I look at del f by del x, what is that? Is y cos z, right? Is this okay?
Yes, it's okay.
Dx by dt is 1. Then del f by del y is x cos z. Then del y by del t is 2t square.
2t.
And then del f by del z is
It would be just 2t.
2. T, right, sorry, 2t. Then del f by del z is
Del f by del z. Yeah, we'll take x and y as constant, and cos z would be minus sin z.
yeah. So xy minus sin z, and then dz by dt is it is what is the derivative of sine inverse?
I think it was something like 1 by root of 1 minus x square, maybe something
Yeah.
like this.
Yeah. So even I don't remember fully, but I think it is this. Okay, so this is nothing but your del f, and now you can match your value and this value by putting your z. What is your z? It is sine inverse t that you have to put here. You will get your y by root 1 minus t square, something like that, and put all the values in t and finally find the value function in t. I think that you can check that this is a same answer that we got. Okay. So here the only thing is that you have to somehow write the function as composition. That is important here. Okay, this is okay. I think this is also easy. Can you tell quickly? This is easy, I think.
Just a minute. If you use the same approach, we will do it in that way.
Mm-hmm.
And this would be easier than the previous one.
Yeah, I think compose this chain rule. This is not useful at least for this case. You will simply say z equal to 2t square and then dz by dt is 4t. It is simple, as simple as. Okay, and then this part I think what is more easy? I think using chain rule will be easy, right? So your function, let's say w is nothing but f compose. I have to be careful here. F uh, g, where g at x. Mm, let me write. So your
In
function
this
is.
one, direct substitution would be even easier.
Uh-huh. I somehow want you to practice for chain rule, because if some question somebody asks you to write the solution using chain rule, like if this you see the question, you have to find the
Okay.
derivative only using chain rule, then you should have a habit of writing that. Okay, let me just practice. Maybe the question we will do it. Let's say some general theory how to produce this. What do we say? The derivatives. Okay, so let's see. Suppose your function is z is a function of x y. X further is a function of r and theta. Y is a function of r and theta. That means you can write your function f as f composed with g. This is okay. I think f composed g. Sorry, what I'm writing. F of g comma h. This is okay, right? If I write k to be some function g comma h, then I can write f compose k.
Yeah.
So, what do you want? Suppose I want to compute del z by del r. Function z is a function of x and y, but further they are function of r, so I can talk about partial derivative of r. That means we want to compute this. That means we want to compute this. Now, how to see this? Let's look at the gradient of f. If you see gradient of f, this is nothing but this. Hmm? Del f by del r, del f by del theta. But using chain rule, function f is composed with g comma h. So g and h are like a variable to that. So I can very well take the partial derivative here, because your function f is a function from R2 to R. But your function k, the way I'm writing k is a function from R2 to R2. And how it has been defined? It is defined if you see g comma h. And g is a function from R2 to R. H is also a function from R2 to R. Uh, Therefore, this is nothing but, so the derivative here will be taken as, so this is nothing but f of g h, its derivative, and then g h derivative is nothing but it is 2 cross 2 matrix because both are function from R2 to R2. Therefore, the matrix has to be from 2 cross 2 matrix, which is take the g with respect to r, take the g with respect to theta, and then take h, and then take h with respect to r and theta. And then take the matrix multiplication and equate both sides, and then you will get what are how to compute del f by del r, del f by del theta. Maybe I'm a bit confusing. Let me write function. Suppose function is from R2 to R, let's say, and g is a function from R2 to R2. Let's say g of xy is g1 xy and g2 xy. Therefore, f composition g is nothing but f composed by g1 xy, g2 xy. Right? This is a real number. This is a real number. It makes sense. Okay. Now, let's see what is del f of g. By definition, you will write as del f by del x1 and del f by del x2. Here we have to variable x. This you want to complete. But function I have written as composition. So I have to take care of that. How would I write that? Del f by del g1, del f by del g2. Only two vectors come if function is from R. But now, when I'm taking the derivative for g, g is a function from R2 to R2, I will get a 2 cross 2 matrix. The size has to be determined by from where to where is the map. If you have 2 to 1, then matrix size will be 1 cross 2. That means row is 1 but columns are 2. If your size is from R2 to R2, it will be 2 cross 2. Suppose it is from Rn to Rm, the size of the derivative will be m cross n matrix. So, therefore, here G matrix will be del G1 by del x, del G1 by del y, del G2 by del x, and del G2 by del y. This is nothing but your del f by del x and del f by del y. Now, take the product of matrices. This is 1 cross 2. This is 2 cross 2. Finally, the product will be 1 cross 2. This is 1 cross 2. Equate both the matrices, you will get what is del f by del x, you will get del f by del y. Is that okay?
Yes, like somewhat.
Okay, I might be confusing. I think this has been done in the class very nicely. I may not be, I'm not able to explain in a nice way, but the idea is if you are composing f with g, as many components g has, if you see the component g has g1, g2, that many times the first vector will come as with the partial derivatives. So since function has g1, g2, two parameters, so the derivative will be only two components. But then coming to g now, g is a function from R2 to R2. So then you will have a 2 cross 2 matrix, and that will be determined by as many components you have and as many variables you have. You just take the partial derivatives. You have two components g1, g2, and you have two variables x and y. You take g1 with respect to x, g1 with respect to y, then g2, and then with respect to x and y. Then you can complete the matrix. This is nothing but a Jacobian. Convince you somehow in a correct way, but if you see the lecture note, this is how you do it. Is it bit convincing?
Yeah, now it's more clear.
Sorry, in?
Now it's more clear on how to do this.
Okay, then I think let's do one example then. Although I'm not very good at although, but let's do it. So F is nothing
Your
but
voice is distorted a bit again.
oh, this connection today is not good at all. Okay, I'll keep writing so that you can follow. So function is this is function of r comma theta, r comma theta. So your f is, which is z, is nothing but right. So f can be written as how do I write the composition? Can you help me?
Yeah, like the function f would be like inside f, we will have functions g and h.
Mm-hmm. So the way we have written is like this. So f of x comma y is same as f of gr theta comma hr theta. It should be okay, I guess. Yeah. So then it is f
Yeah.
compose g comma h r theta. Is how right? Yeah. Okay. Now, how many components f is applied to a function which has two functions g and h further, right? Okay.
Yes.
So if I write del f by this, the gradient f, this has how many components? It has del f by del g and del f by
Del h.
del h. Then g and h are further functions.
Yes.
But they are functions from R2 to R. Remember, G is a
Yes.
function from R2 to R only. So how what size of the matrix will come?
R2. So it will be 2 cross 2 matrix.
No. It is function from R2 to R2, right? Sorry. Yeah, you are right. I think it is 2 cross 2. Why? Because we are taking composition G comma H. Yes. So therefore, it will be del G by del R, del G by del theta, del H by del R, del H by del theta. But this function is same as del F by del R and del F by del theta. Now equate. Del F by del R is simply del F by del G. So I'll take the product first. Del F by del G by del R, plus del F by del H by del R, comma, del F by del G by del R, plus del F by del H by del theta. Is that okay?
Yes.
I think I am making a mistake here. Del G by del theta.
Uh,
This, and then this, and this. It's a matrix multiplication, so we'll get this. Del G by del R plus del F by del H into del H by del R. This is first thing. Equate them. Del F by del theta is del F by del G by del theta plus del F by del H by del theta. This is okay, right?
yes.
Okay, now let's compute. I think now I will leave. I am not computing. I am also getting confused. Okay, so you can simply put these functions, then compute what are partial derivatives, but you can also use these two things. I think now roughly you know how to do. Maybe if you practice 2-3 functions, you will do it.
Yeah.
Okay, what else? Oh, this is, suppose this is certain generality. I think now you can tell me this. Suppose f is a function of three functions u, v, w. Each function u, v, w is further functions from R2 to R3. Now, can you tell me what is del x by del h? Remember, use the gradient first, del f. Sorry, del h. I think this is our h, del h. So if you see h, This one can write as f of u comma v comma w. This is okay, right? Now
Yeah,
f has parameters. So if you first write the vector for the f, how many partial derivatives will come? This by definition is this. But for f, it has three parameters. So del f by del u, del f by del v, del f by del w. Now for UVW, UVW are functions from R2 to R, but then you have to see. So what did I do? Did I make mistake? No, I think it's okay. Now, can you tell me what is the size of the matrix which will come? This is 1 cross 3. First, 1 row 3. Yeah. This is 1 cross 2. Can you tell me what is the size of this matrix so that you can equate it to
it
1
would
cross
be
2?
3 cross 2.
Yeah, but how to write that? I think it is easy, right?
Like, yeah, it would be like in the first row, we'll have del u by del x and del u by del y.
Yeah.
Then the second one, del v by del x, del v by del y.
Yeah.
And then the third one, del f by del x, del f by del y. No, del w by del x, del w by del y.
Right. Now you can equate, right? The size of the product of this matrix will be 1 cross 2. And then you can equate and find what is del h by del x and del h by del y, right?
Yes.
Okay, so I think I I leave this and there are some more. Maybe quickly we do this and we will end. It is already so many things we have discussed. Level curves of these following surfaces. What do we mean by level surfaces? Level curves for a surface?
Like in case of a 3D figure,
Mm-hmm.
the level curve would be a curve representation of that original figure so that we can visualize it in 2D.
Right. This is geometrically what you are saying is correct. Basically, you are visualizing your 3D figure by 2D figure somehow by putting the third constant as a constant. See,
Yes.
suppose you have function like z equal to x square plus y square. The first example. We want to find the level curves. What do you mean by level curves? Now, can you tell mathematically how will that be?
So we will take x square plus y square as some constant c.
Yeah, so put z equal to c, then you will into the two dimension situation x square plus y square equal to c. Now what is this?
And if you trace it, we will get a circle with origin at 0, comma 0 and radius root of c.
Right, root c is the radius and the origin is 0, 0 is the origin for the circle. Yeah, center of the circle. So clearly it is nothing but, so the level curves you can see here, level curves are circles. Level curves are circles. What can you say here? Radius. For the second part, I think it's not direct. You have to just simply compute something, then
No,
you will
it's
get
not
it.
direct.
It's not direct, but it can be done. Just keep writing. X square minus y square by x square is c is the level curve. Directly we cannot leave it. We have to tell what geometrically the meaning. So x square minus y square is c time x square plus c time y square. X square 1 minus c plus y square 1 plus c is 0. This I think it's not useful. Can you do some more manipulation? I think let me write x square minus y square is c times x square. Can you do some more manipulations to get it? I think you can do like this. No, I think you are writing correct. It should be x square 1 minus c and y square 1 plus c. Simply write y square by x square 1 minus c by 1 plus c. It's another constant, right? If I write this to be some a, there is no harm writing, right? So I can simply say this is nothing but y square equal to ax square, which will give me y equal to plus minus ax root ax. This is okay, right? So what
Yes.
does it represent? It represents two straight lines, right?
It
So
presents two straight lines.
yeah, I think one is in the
It
negative
will
side and
pass
one is,
through origin.
yeah, it will for sure pass through regions. One is positive, one is negative, like that. You see, if I put a to be 1, then it is y equal to x and this is y equal to minus x. So you can say the level curves here. So level curves are pair of straight lines. This is okay, right?
Yes.
Let's quickly, I think gradient I will leave. Gradient one can find what is the gradient. I will simply write it is del f by del x, del f by del y. This is nothing but the gradient of f. Let's look at another question. I had some more things to tell, but how many people are there in the meeting? Let's look at that. Do you want to listen some more things if I say? Yeah, or is that enough for today?
I think it's enough for today. We can take it in the next class.
Sure, sure. No, I can understand it's, I think it's too much to discuss. Okay, so then we will stop here. And thank you so much for coming.
Yeah, thank you, ma'am.
Okay. I'll just stop recording. Okay, then